So we're going to integrate using partial fraction decomposition, x squared minus x plus 6 divided by x cubed plus 3x. Our first step is, before we can do the decomposition, we always have to factor the denominator. So factoring the denominator, I see it can factor out an x, and that leaves me with x squared plus 3. So we are going to have x squared minus x plus 6 over x times x squared plus 3. And we're going to have a two-fraction decomposition. So we're going to have x as one denominator, and x squared plus 3 is the other denominator. So for the decomposition, the fact that x is degree 1, I'm going to put a degree 0, or constant a, above x. Because x squared plus 3 is degree 2, we're putting a degree 1, which would be bx plus c. So now I'm going to do the rocking chair here. So I have a times x squared plus 3 plus bx plus c times x. And I'm not going to finish the denominator because the two denominators will be the same. But that numerator part has to equal the original x squared minus x plus 6. I like the method where we substitute values. So I'm going to let x, the first x I'm going to let be 0, because that's going to 0 out over here. So letting x be 0, I get 0 minus 0 plus 6 is a times 0 plus 3 plus all of this times 0. So it's really b times 0 plus c times 0. Well, that's zeros out. So I get that 6 equals 3a. So that makes a equal to 2. So now I'm going to choose another value. In fact, I'm going to have to choose 2 more x values to get b and c. So arbitrarily choosing, I let x be 1, and I substitute in here, and I have 1 minus 1 plus 6 equals a times 1 squared plus 3, a times 4, plus b times 1 is b, b plus c times 1. Now working this out, I get 6 equals 4a plus b plus c. So now I do know a, so I can at least put a in, and I get 6 is 4 times 2 plus b plus c. So subtracting, that's 8. So subtracting that, I get, and I'm going to write it left to right. Right to left. B plus c is negative 2. Okay, so now I am going to choose another value for x. This time I'm going to let x, I'll just let x equal 2. So substituting in this, I get 2 squared minus 2 plus 6 is a times 2 squared plus 3 is 7, 4 plus 7, plus 2b plus c. So we've got 2b plus c times 2. So this is 4 minus 2, 2 plus 6, I get 8 is 7a plus 4b plus distributing the 2 through 2c. So now I'm going to substitute for a, which is 2. So I get 8 is 7 times 2 plus 4b plus 2c. And that was 14, so I'm going to subtract the 14. And I get, writing it right to left, I get 4b plus 2c is negative 6. So putting this over here, this was one equation. Now I have 4b plus 2c is negative 6. All right, guys, so I'm going to multiply this one by, negative 4. So I get negative 4b minus 4c. Negative 4 times negative 2 is 8. And now I get that negative 2c is 2. So c is negative 1. So now the fact that c is negative 1, b plus c is negative 2. I have b plus negative 1 is negative 2. So sure enough, b, everyone, it turns out to also be negative 1. Okay, so I've gotten what a is, I've gotten what b is, and I've gotten what c is. And now I will replace a, b, and c for my partial fraction decomposition. So we go back here and we see that I'm going to let a, let's see, a was 2, b was negative 1, c was negative 1. So a is 2, b was negative 1, c was negative 1. So we've got a nice decomposition. So I'm going to rewrite the problem with that decomposition. So the problem was the integral of x squared minus x plus 6 over x times x squared plus 3 dx now is written with the decomposition, and it is 2 over x plus negative x minus 1 over x squared plus 3 dx. We now have two different parts of this antiderivative. Okay, so we are now going to separate this. This will be 2 the integral 1 over x dx plus the integral negative x over x squared plus 3 dx plus the integral negative 1 over x squared plus 3 dx. The first one is fairly straightforward. The second will be a u substitution. And the third is a memorized inverse tangent. I'm going to go to the next page and rewrite this, and we'll finish. Okay, so this will be a u substitution. U will be x squared plus 3. So du is 2x dx. So a half du is x dx. So this integral will just be negative a half, because of the negative there, du over u. So it's negative 1/2 the log of absolute value u. This third one comes from the formula. It's just 1 over a inverse tangent x over a. But a squared is 3. So a is radical 3. So this one will be 1 over radical 3 inverse tangent x over radical 3. And sure enough, this is just 2 log the absolute value of x. So now completing this, we get 2 the log of the absolute value of x. This is minus a half the log of, well, the u value was x squared plus 3. And this one, with the minus in front, it's minus 1 over radical 3 inverse tangent x over radical 3 plus a constant. So although it is large and very long, we did it in an easier way with partial fraction decomposition.